Well, hello everyone, and welcome back to Adrian's Digital Basement. On today's video, I want to revisit the Commodore 1702 monitor I have on the bench, which last year, I think, swapped in some brand new guts into it from one of these AliExpress television boards. This board was a really good upgrade to the monitor, actually, because it gave me the ability to access both PAL and NTSC video signals, while the original 1702, at least in North America, was only capable of displaying color NTSC signals. It also added a tuner, which allows me to hook up old 8-bit computers that don't even have video output, that have RF only. I've been using the monitor upstairs in my office since I did the video on it, and it's been working absolutely flawlessly. But there's always been one thing about it that kind of bothered me, and it's not a failure of either the board or the conversion I did. You'll notice on the bench I have both a Commodore 1084 and a 1702, and the reason why is there's a difference between these two monitors. What comes to mind when you think of the 1084 versus the 1702 is that the 1084 supports RGB, both analog and digital. But that's not the reason why I have them both on the bench. The other big difference between these two monitors, besides the fact they're made by different manufacturers and they look different, is the CRT itself. The one in the 1084 has a lower dot pitch, which gives it the ability to resolve higher resolution text. And I took a few pictures with my phone, which allows me to do a macro shot, and you'll notice that the CRT in the 1702 does a much worse job resolving 80-column text. And compared to the 1084, it has a lower dot pitch that allows it to resolve the text more clearly. So in this video, what I want to do is I want to try to swap in the lower dot pitch CRT from a 1084 into the 1702 to basically make one of the highest resolution color Commodore 1702s that probably ever existed. So without further ado, let's get right to it. When comparing the CRT that's in these two monitors, they're both physically the same size, but the 1702 is using what is known as a television grade CRT, while manufacturers started making CRTs like the one in the 1084 that have a lower dot pitch that are able to resolve higher resolution. And this was done specifically because they started making computer monitors that needed to have the ability to display high resolution text, like 80-column text clearly, but also display them in color. Early on in the history of computer displays, when you were displaying color, you would use television-grade CRTs like the one in this set because they were inexpensive and very commonly available. But if you were going to be displaying high-resolution text and needed that sharpness, you would default to monochrome CRTs because they lack the shadow mask and wouldn't have problems resolving the high-resolution text. When computers with high resolution but also color display capabilities were introduced, then the need for CRTs to be able to display high resolution text and graphics became much more common, and then you really started seeing a lot of these low dot pitch type CRTs available and in use with computers. And these did a pretty good job of displaying the 80-column text along with vibrant colors. But there were trade-offs going from the television low-resolution CRTs to these high-res ones. And what it was is the amount of phosphor that's on the front of the screen was actually less, because if you think about the fact that the RGB matrix, it's repeating over and over again, has little borders in between the colors. Well, when you shrink down the matrix and the phosphor dots get smaller, then the lines that are around them end up taking up a larger percentage of the front of the glass. And the lines in between the RGB phosphors don't emit light. Therefore, it's just not as bright. And to get them equivalently bright, you have to turn up the drive even higher on these, which has the side effect of wearing them out and causing blooming if you turn it up too much. That's why you might notice whenever you look at a 1702, these often look bright and vibrant compared to 1084s, and that's really just because they don't have to be driven as hard to produce the same amount of light output as the 1084s, therefore they don't wear out as quickly. All right, I've opened up the back of the 1702 with the AliExpress board in it, and here on the right is an old television set that has no guts in it except for the CRT, and I'm just using this as storage. This CRT actually comes out of a Toshiba-made Commodore 1084. The rest of the monitor was completely destroyed, so all I have left is this and a few parts from the main board. And what I wanted to demonstrate here is the size of this CRT is the same. I could take this Toshiba one and mount it in the 1702 chassis and it will fit without a problem. The issue is what's on the back here, the deflection yoke. The thickness of the neck is typically different between these low dot pitch CRTs and the high dot pitch CRTs. The high dot pitch CRT I have here is about 30 millimeters, and the low dot pitch CRT is about 23 millimeters in diameter. In addition, the connector where you plug the neck board in, right here, is also different between these two CRTs. The actual signals that go into the pins is basically the same, but for whatever reason, the number of pins on the connector is different. And that means the connector that you have on the neck board is not going to work if it's one designed to plug into this size CRT. It seems what manufacturers did is they took the neck that would normally go on a 19-inch CRT and grafted it onto a 13-inch CRT. So the thickness and the deflection yoke and the convergence assembly and the connector are all the same from a 19-inch CRT as a high resolution or low dot pitch 13-inch CRT, like the one we have right here. It means the deflection yoke in the 1702, which I know works well with this particular CRT driver board, will not fit onto this CRT. So if I swap these around, I can't use this deflection yoke. I'd need to use a deflection yoke that's designed to work with one of these CRTs. Now, these problems shouldn't be insurmountable because if you recall from the installation video on this monitor, there are actually two different connector types that this little neck board supports on the AliExpress driver. That means I can swap this over to the correct connector that this CRT uses, and then I can just cut these wires or even temporarily hook these up to the driver board here so we can just see if this deflection yoke for the 1084, this is the deflection yoke that actually came with this CRT, works with this AliExpress board. So first things first, I'm going to disassemble the 1702, get this CRT out of here and disconnect the deflection yoke and all the cables and mount this 1084 high resolution CRT into this chassis, and then we'll figure out how to get it connected up and see if I can get it working properly. Okay, change of plan. Inside the box that I was showing earlier, I actually had to spare one of these AliExpress boards. So I decided, because this board already has the right connector to plug into this higher resolution CRT on it, we're going to do testing to make sure this higher resolution CRT and the deflection yoke is compatible with this board first before I take apart the 1702 completely. Before I power this up, huge caveat, of course, this is high voltage and there's a bunch of danger in working inside CRTs, so do not open up any of your CRTs or try doing any of this swapping unless you know how to do it safely. For my safety, I'm going to be using an isolation transformer from the 120 volts mains. That's what this top one is. And then this bottom one is a step-up transformer to 240 volts because this CRT board has not been modified to run on 120 volts like I did the one in the 1702. So that one doesn't need a step-up transformer. Although, incidentally, I've heard reports of people using this exact board plugged directly in 120 volts and it worked just fine. It uses a switch mode power supply to generate the B+. It's quite possible that it's fully compatible with 120 volts. It's just the specs for this just said 240. It didn't say it was multi-voltage compatible. But as I mentioned, I know someone who's using one of these boards and they just plugged it into 120 volts without thinking, and everything is working perfectly. But because I already have the step-up transformer and the isolation transformer, I'm just going to use those. I am just clipped onto the power lead, so that's not super safe. So just FYI, don't do this. It's just for testing. The deflection yoke that's on the 1084 luckily has the correct connector that can actually just plug straight into this board. I don't need to cut it or do any kind of adaptation. The only caveat is there is some additional pins next to the flyback that allow you to adjust the width. And I know it's a little bit hard to see, but I would need to take the red wire that's coming from the deflection yoke and try out these various pins next to the flyback. The pin that it's currently connected to, the red wire right there, that pin is currently connected to the middle pin of these 5 pins next to the flyback transformer. So if this does work and I find the width of the picture is not appropriate, then what I'll do is I'll de-pin the connector that's plugged into the board and I'll try out these other pins next to the flyback just to see if one of them works better than the others. The high voltage anode is connected. The neck board is plugged into the CRT. I have the ground lead from the CRT also connected to the neck board. That's absolutely essential. And I have the IR receiver connected so we can use the remote control to turn it on and control it. So I think it's ready to go. So I'm going to rotate this around and I'm going to turn this on in 3, 2, 1, Power on. Oh, there it goes. I'm glad to see my isolation transformer did not blow. This has 2 fuses in it, and I looked at the fuses, and it seems like it's only rated for about 45 watts, but I don't have the degaussing coil connected right now, and that's the biggest power draw on something like this. And there it is. I fed a video signal into it. Looks pretty good, although I'm noticing some issues right off the bat, and it looks like this thing has some pin cushion going on. That's where the image is curving inward towards the center. So the lines in the center aren't as wide as the lines on the top and the bottom. We can see that the overall deflection looks pretty good, and it's relatively sharp as well. Not seeing any massive issues with linearity or convergence or anything like that, but yep, we definitely have quite a bit of curvature happening on both sides of the screen. So I'm going to go into service mode, and that happens on this set by pushing this little hidden button on the remote. So we hit once and hit twice, and then we get into the service mode. Now the stuff we're looking at right here has to do with the drive and the bias controls for the CRT. So this stuff is fine. If we had color bars that didn't look good, even though the color decoding settings in the main menu would be, if you set them in the middle and the colors look off, then you really have to go ahead and adjust the drive and the bias controls. And if you push the button 0 on here, you end up with this service mode line. Basically, it's dim the image way down, and then you can adjust those drive and cut controls to get this line looking a nice gray color, and then that should make the normal image look better. But that's not really our problem here. Our problem clearly has to do with deflection. And on page 2, I think it is, where is it? Page 1. Page 1. These are the deflection controls for the set. Now, what we have available to us, we have a phase control, so we can move it horizontally left and right. We have a vertical size control, so it shrinks and grows the picture, so that looks fine. We have a position control for vertical. We have a linearity control, and we have this one. I can't remember what the SC stands for. What this one does is it kind of scrunches the top and the bottom of the image, so you notice the boxes look a little bigger in the middle than they are at the top and the bottom. So you want to get this set where the boxes on the top and the bottom are essentially the same size, well, vertically at least, as the ones in the middle. And then you would increase the size so they're all square. Now we have 2 horizontal controls that maybe have to do with this curvature that's happening, but what we're looking for is a pin cushion control, and it doesn't seem that this thing offers that. So there's H-bow, and what does this do? Okay, so what we can see what this does is it's taking the top and the bottom of the image, and it's curving it this way or this way. And if I go between the extremes of the control, there's only 0 through 7 available to us. Now the curvature is very extreme over here. Now it's a little less bad, but it's worse over here. Now, funny thing is, I'm noticing, it's hard to see because I'm not looking straight on, feels like there's more curvature happening here than on that side. And if we flip this the other way, then there's less here, but now there's more there. So that control, unfortunately, there's just not more adjustability to it. But even if we had more adjustability, I don't think we'd ever get this working properly because we would get one side looking vertical and the other side would be quite curved. And then there's this parabola control, right? So this takes the entire image and it's like a parallelogram. If you imagine the box of the picture, and if you move the top and bottom this way, then the sides end up going like that. So all of the lines move that way. So that doesn't help us. That doesn't help us either. Nope. These have to do with the vertical blanking of the image at the top and the bottom, and then this is some kind of a vertical centering control, which is different than vertical position. I can't remember what that does exactly. And then everything else in here, and I went through this on the video for the Commodore 1702 when I did that conversion, has to do with chroma, color decoding, tuner stuff, menu things. None of this really has much to do with deflection, or has anything to do with deflection for that matter. Automatic frequency control or automatic black level control, that's chroma decoding. Yep, so this is tuner related stuff, and again, tuner and FM has an FM mode on here, although I never figured out how to make that work. This has to do with some additional outputs from the main Jungle multi-function controller chip that's on here, and you have to set some of these so that you can get this thing to output or input S video, and I think maybe also for component video. Menu related stuff, language related stuff. This is also on-screen display things. This is tuner, world standard related stuff, along with input things like AV2 and YUV, that's component input. This has to do, again, with on-screen display type things, color temperature, sub brightness, on-screen display things, and yep, that's unfortunately really it. So I think what's happening here is that the impedance or something in the design of the deflection yoke that's on this CRT, the one that came from the 1084, is not really compatible with this particular driver board. Obviously, it's most of the way there since it's looking okay, but the pin cushion is our problem, and that's not adjustable on this particular board. Now, one of the things we can try is moving that red wire from the deflection yoke that's plugged into the main driver board and plug it into those 5 pins that are next to the flyback transformer. That should have the effect of changing the width of the image, the overall width of the image. But I recall playing around with that on the 1702, and it did do that. It affected the width, but it had no effect whatsoever on any kind of pin cushion effect that we're seeing on this particular TV. Now, I wouldn't be surprised if we take a look at the Commodore 1084 schematic, maybe there's some part of the horizontal drive circuit that compensates for this pin cushion effect. I've seen some sets actually have an adjustment potentiometer on the main board to adjust this exact symptom. So I wonder if we could find some schematics for one of those sets and replicate or copy that part of the schematic or modify this board to have a potentiometer to allow us to adjust the pin cushion. Another thing, and I want to keep this as a last resort, is in this box I've collected about 3 or 4 other deflection yokes that should fit on this CRT. These came from junked 19-inch TVs that were being recycled. I took the cover off and stole the deflection yoke before they got recycled in the hopes that one of these might be compatible with this particular CRT and driver combo and get rid of this particular problem. I want to keep any swapping of the deflection yoke and taking off of the convergence rings as a last resort though, because taking the deflection yoke off means that you're going to have to do an entire setup on the CRT. And what I mean by setup is the position of the deflection yoke on a color CRT is very critical for the color purity and the convergence of the different beams. And anytime you take it off and put it back on, you're going to have to go through that whole process again. And I have to say, I'm not good at that process. I have done that swap before, and I never really managed to get the convergence as good as it was from the factory. And you end up with the corners of the image where the red and the green, the blue lines don't come up together anymore. And if you're talking about a monitor where you're going to be displaying text on it, that's not exactly ideal. You want the convergence to be as good as possible, and those little wedges and the little magnets and all these other little things that are going on under the deflection yoke were set up at the factory by skilled, trained technicians who basically displayed test patterns and know exactly how to do all that adjustment, and I don't really know how to do that very well. But I suppose on the other hand, this is a spare CRT and these are spare yokes, and if I'm not using this CRT, then what does it really matter? It would be cool to actually be able to use this in the 1702 and have that nice high resolution. So if we get to that, we'll definitely be swapping some yokes out. Let's take a look at this manual for a Sony CDP 1604. Being a high resolution computer display monitor, or VGA monitor really, Sony added in tons of things for adjusting this. So there's the parallelogram adjustment, just like this TV has. But there it is, side pin, RV310. This adjustment would be exactly the one that we need if it were on this TV, of course. Now looking at this circuit on the Sony, it uses an LA7850 as the horizontal oscillator. And there is the horizontal drive transistor, 2SA812. In this section, we see the various pin cushion control circuits. And now here are the side pin adjustments. This schematic doesn't seem to match what was up above because we actually have side pin L and side pin H. And those signals feed into this IC, which is this one, TEA2031A. And I have the data sheet for this. So color TV east-west correction, built-in frame parabola from external sawtooth. This chip is intended to ensure frame rate modulated parabolic and keystone corrections to the horizontal deflection circuitry of 110-degree color TV sets. The linear frame sawtooth is applied to the appropriate circuitry from which a corresponding parabolic waveform is obtained. So there are 2 signals that go into this chip. There's the line sawtooth that essentially is telling the chip where on the horizontal line the beam is currently scanning. And then there is a separate frame sawtooth signal. That is a sawtooth that's generated as the beam scans vertically. So vertical deflection powers this. And then the output to the diode modulator. I wonder if we have some graphs we can look at. All right, here it is, figure 2. What's happening is essentially, if you can imagine a width control, say there was a virtual width control. So let me draw some terrible thing. So imagine this is how the pin cushion is looking on the CRT. So this is, imagine the picture tube. I'm using a mouse. It's very hard to draw straight lines. So the image is squished internally. What happens, and we saw it on the graph right here, is as the beam, let me change to a different color. As the beam starts scanning down the picture tube, there's that sawtooth waveform which is generated. That tells the chip where the beam actually is scanning. Well, in this middle section, it applies this curve like this, to the horizontal width control. So it basically is adjusting the width of the scan lines as the beam scans down to compensate for this pin cushion effect. And it can work backwards. I think as you turn the control the other way, theoretically it can I don't know, it can generate a signal like this. So in the case of our TV, right, we're dealing with now, the picture is bowed out. So what needs to happen is the lines in the middle need to have the width reduced. So if the waveform going to the width control was like this, and it would be like this every single frame, then it would reduce the width. That's what this chip is doing inside the circuit on the Sony television. And there are various controls here for pin balance and pin phase and all this type of stuff to get those things tweaked and dialed in perfectly. Now here's the key point though, is there needs to be a horizontal size adjustment control, and one that's controlled via voltage, because remember this outputs a voltage and it needs to be applied to the horizontal size. And you can see that it is. This is connected right here to the horizontal size adjustment. And you can see that this goes to this part of the circuit here for horizontal size, L and M, whatever that means. And that, as part of this horizontal drive circuit, allows that width to be corrected as the frame is scanning, and that's the pin cushion correction. Now going to the schematic on the AliExpress board, this is a lot more simple. So there's a vertical out, there it is, horizontal out, goes through a couple resistors, it's a divider, and then that makes its way over to this part of the circuit. There's a transistor with a few little components here. This drives a small transformer, and this component here, V432, that's the horizontal output transistor. And unfortunately, that basically drives the deflection yoke and the flyback transformer directly. There is a little bit of components here which I think allow for some adjustability. And in fact, this control right here allows you to adjust the width on this set. Well, it's not adjustable, but you could theoretically swap this out. Also, I think this capacitor, or no, it's this capacitor, C435. This also can help you adjust the width and tune the circuit. But if we follow these traces, they go right to the horizontal deflection yoke. What this means, there's no provision on the circuit to actually do any kind of real-time adjustment of the width, especially while the beam is scanning. Now, it does appear that there is a vertical sawtooth that is output from the chip. It doesn't seem to be hooked up to anything except for this small capacitor. And when it comes to horizontal, there's this 14, which is probably an input automatic frequency control. Looks like there's some capacitors here that probably help stabilize that. Horizontal out, and then I think this FBP in, this has to do with flyback transformer. I think this, if we follow this trace, that likely goes, let me just make sure my eyes stay traced on it. This almost certainly goes over to the flyback transformer. Yeah, it's this trace right here. Yeah, it goes right there to pin 8 on the flyback, which, what is that hooked up to? Ah, the heater. This is almost certainly allowing it to monitor what's happening with the flyback and try to regulate the voltage. The heater would be 6.3 volts on a color CRT like this, so it's able to just make sure the flyback is running properly. Probably if it detects any kind of anomaly on that line, it will shut down horizontal, which turns off high voltage. Now this is the data sheet for this Toshiba chip that runs the set. Now it is in Chinese. We can take a look at the pins here just to double check. Horizontal processing, sync separator, horizontal automatic frequency control, H shift, so that would be moving it left and right. There's that flyback feedback circuit going back into the chip, horizontal output, and then the automatic frequency control. And then there's vertical processing here for geometry, ramp, drive, etc. And that has that sawtooth signal right there. Looking at a Google translated version of this PDF, VSaw connects to external sawtooth waveforming capacitor. So perhaps this capacitor tunes the vertical somehow. And then the automatic frequency control, circuit, external, filter, connection terminal, and line drive pulse output. I'm searching the entire document for width. Vertical linearity field width. I guess that's talking about the height, not width, but whatever. Translation error, I'm sure. Okay, that has to do with frequency modulation. This one has to do with audio as well. Adjust the PAL linearity and line and field width. Again, that's the height of the image. And that's it. We've looped around. So there really is no control or discussion about picture width at all with this chip. And looking for the word cushion, there's nothing. Yeah, I feel that there's no compensation or control over those features at all with this chip. It just relies on the circuit tuning of the deflection yoke, I guess, to work properly. Which really means there's no way, at least that I'm aware of, to adapt the circuit on this set to do any kind of pin cushion compensation, as we definitely need to have a variable width control based on voltage if we're going to use that chip, this one right here. So I think there's nothing really to be done, unfortunately. All right, I've done some stuff. So this deflection yoke is one that I pulled out of my box, the one I showed at the intro. Looks like it's got some very flaky tape on the inside. Notice there's little correction magnets and things in there. Anyhow, what I've done is I measured the inductance of the deflection yoke on this CRT and the one on the 1702, which is working really well. The inductance of the horizontal winding on the 1702 monitor is 2033 microhenries. And then the vertical is 33 millihenries. Now on this deflection yoke, the one that's on here that's not working very well for us, the vertical is 21.3 millihenries versus 33 on the other one. But the horizontal is 1474 versus that 2033. So is that the difference that's causing this issue? I don't know, maybe, maybe not. I also measured some random Samsung CRT and deflection yoke I had laying around. It was 22.1 millihenries on the vertical, so kind of similar to this one here, the 1084, but the horizontal was 191 microhenries, which is substantially different, 191 versus 2000 on the 1702 and 1400 on this. So maybe if we tried to use that Samsung, it would be super bowed in. And then I went and I measured the deflection yokes in the box. There were 3 that are the right size, the larger size that should work on here. And this one, horizontal, 2291 microfarads, which is almost identical to what's on the 1702, which seems to be working really well. And then the vertical is 31, which is very similar to the 1702 monitor as well. So I'm pretty confident that this deflection yoke, even though it's pretty gross and obviously came off a very, very well-used TV, should work, maybe? But what I also did is I depinned the deflection yoke connector so that we can try those different pins next to the flyback. I apologize, there's a ton of wires, but those are the pins. And there are indeed 5 of them. And the middle pin I know is the same as the pin we were already connected to. So I have it hooked up to the pin that's closest to the back edge of the board. Let's see what difference that makes. All right, here we go. I'm going to turn it on. 3, 2, 1. All right, there's high voltage. So that's working. Okay, well, it doesn't really look different. If anything, I must have bumped the screen control because the picture just looks a little bit brighter than it was. Yeah, I'm not really seeing much of a difference at all. I'd say that moving that connection to that pin made the entire image wider, but it seems to have no effect on the pin cushion whatsoever. All right, it's now on the pin closest to the front of the set. Let's turn this on. See, the set has power. It takes a moment to turn on. Okay, well that had a dramatic effect on the width. It's also a lot dimmer, so maybe that had to do with the amount of high voltage being generated. Remember that the horizontal drive is directly correlated to the amount of high voltage that's being generated. Potentially, it's generating less now. And there's definitely an impedance matching going on between the deflection yoke itself and the entire circuit and the flyback transformer. And I suppose that this dimness is one of the side effects of not enough horizontal deflection. But what hasn't been fixed is clearly our pin cushion issue. It is still there. So moving that pin around, that had no effect on the pin cushion. I'm just going to quickly try the other pins. So of the 5 pins, I was on the one that was closest to the front of the set. That was the one we were just looking at. I moved to the pin 1 off from the middle, so 1 back. See how that looks. I'm presuming the picture is going to be wider. Yeah, it's obviously wider, but that's clearly still too narrow. We have some fold over happening on the side here as well. Okay, I just moved it back to the middle pin of the 5 pins. Let's see what that looks like. The image is brighter and is wider as well. Yep, we can see some of the edge right there. It's funny how there's a dramatic change from just one pin over to this one. Now with the 5 pins, this being the back of the monitor, I'm on this pin right here. The one we were just on, that was the middle pin. That was the same as the stock connector. Oh, interesting. That's narrower as well. All right, well, anyways, I tried all 5 pins. It made no effect on the pin cushion. It just changed the width and the brightness and overall. And that middle pin definitely looks the best with this particular deflection yoke. But I think at this point, what else is there for me to do but try this deflection yoke, which seems to match the 1702 one the best. And yep, I think that's all there really is to do at this point. First, we got to take off these convergence rings. It looks like I might have already done that because I see some paint marks that I drew before with a Sharpie. So I used a Sharpie to draw some marks on the tape, and I've loosened this clamp. You see the clamp is loose now? Now I need to try to get this off. Oh, there we go. That came off pretty easily. Sometimes it can be very stuck. So I don't want to turn any of these. If I want to put it back on, that's what those registration marks are for. But now this yoke has to come off. So, and I guess what I should do is also draw some registration marks on the tape here, just so I know exactly how far to put this on. Now, part of it, of course, is that it's up against these little wedges. See these wedges right here? And that's part of that alignment process. And there's some glue in there as well. So even though this clamp is loose now, I'm going to try to twist this to break the glue. There we go. So we can slide this back, loosen this clamp a little bit more. This tape is making it a little hard to get off. There we go. There's the inside of this yoke. It also has some of these little magnets they stuck in there. That's for correcting small geometry issues. That's the glue that was on these wedges. I'm not going to touch those wedges. First, I'm just going to try this other yoke on here. The reason why is these wedges may need to be moved, but I'd rather leave them there because if this yoke doesn't work, then I'm going to put the other one back on here. Because if I have a 1084 that has a very worn out CRT, I think this is upside down. I think it's probably this way. I don't know. We'll find out if I have this on upside down or not in a moment. No, probably it goes that way actually. So this one, you may notice, has the convergence rings built into it. I noticed that taking these off some TV sets. All right, so one of the problems is it has these little tabs and they're bumping up against the wedges. So realistically, I need to take these wedges off to even get this one all the way on. Maybe what I need to do is just try it out this way, not all the way on, just so we can see if it still has the issue with the pin cushion. Because if it does, then, like I said, I'm going back to the other one. I'm just going to plug the deflection yoke connector straight into the board. It looks like it's got the right connector. Now I fully expect, because the yoke is not pushed all the way forward on the CRT, there's going to be a lot of color issues, but I'd say it's going to be enough for us to know that it is going to have the right geometry. Okay, I have the cable unplugged, even though this has a power switch, still just double safe. Okay, here we go, turning it on, 3, 2, 1. All right, I hear high voltage. Nope. Okay, we had no vertical deflection there. There was horizontal deflection, but no vertical deflection. Let's see what happened there. Oh, I see the problem. This connector has more pins on it. So I'm going to have to, oh, I can just repin it. That'll do the trick. Wow, I spent like 20 minutes trying to depin that and I was not successful. I just ended up cutting the connector and swapping the vertical pins around. So basically I cut the end of the connector off, took the vertical out. So when we get this thing powered up, vertical is going to be swapped. But that's something I could fix later. I have all these little depinning tools, and unfortunately they were just bending. I don't have the right tool to depin that connector properly. All right, we are ready for try number 2. Let's plug this in. Power's on. I'm ready to turn this off in case we have an issue again. Okay. Well, it looks like there are no deflection issues whatsoever. Obviously, we have convergence issues. We have all sorts of color problems, but that's because the yoke is not pushed all the way forward. But look at the line there. That looks good. That looks freaking good. Let's turn this a little bit more. Yeah, look at that. There, I turned off the overhead light so it's a little easier to see. That looks so much better. And yep, oh, it's horrible convergence, but look at the deflection. Looks good. No more pin cushion at all. So obviously the pin cushion issue that this thing was having was due to that inductance difference on the 1084 yoke. Okay, we're looking at a full field red. You noticed it's obviously have some issues with the beam landing. That's alignment of the beam hitting the shadow mask behind the glass, and so it's just not hitting in the right place, and this is what you end up with. And I guess it's time to remove these wedges. I see some hot glue on here, so it actually looks like I had taken these off in the past. So there, the 3 wedges have been removed. Okay, I'm running into an issue here. This, let's take this off. Don't want to risk breaking anything. It doesn't seem to want to go on any more than that. It just sort of hits a hard stop. Now I'm wondering that this came off a 19-inch set. Is this angle significantly different on a 13-inch set than on a 19-inch set? In other words, are these yokes incompatible? I'm putting this on backwards. I just want to see if it can slide over all that tape. It can. Not an issue. Yeah, I think this is not compatible. The one on my left hand is the yoke from this set, and the one on my right hand here is the one I was trying to use, and they're different. I mean, I guess it kind of makes sense that the curvature of the glass here is different on a 19-inch CRT compared to a 13-inch. I've frankly not done much work with 19-inch CRTs, so I just kind of assumed if this side was the same, that it would have worked, but that's not the case. Now I do have these other ones. These are the ones I measured and weren't as good of a fit as the one we were just trying. I can try these on here just to see if they are any different. This one is super rusty. I think this set was like outside or something horrible happened to it. Yep, same thing. It just kind of hits a hard stop, and there's still a really big gap here. And then this is the last one I have, which looks like it's pretty dirty in there. Something just broke off this one. That's, oh, the plastic pieces on this one are falling apart. I think it's been heat soaked quite a lot. Yeah, basically same problem. This one seems to slide on a little bit further, but still not all the way. That certainly presents a problem. This was my fallback, and my fallback is a fail. Okay, so at this point, I need to think about what to do next, because obviously I'm stuck and this can't possibly work. All right, the 1084 yoke is back on. It's not in the right position, but I just have it loosely attached. I have 2 of the wedges back on there. Luckily there was hot glue and I could kind of see where they were, where this was all aligned based on the registration mark. So I think it should be relatively okay. But what I've done is I found this inductor on another old CRT board. It's about 200 microhenries, and I have it in line with a horizontal deflection yoke. So I'm really kind of curious what this is going to do. Obviously, we have clip leads going on here. This is kind of dangerous. We have pretty high voltage running through those wires. So I'm going to keep this right there so it's not close to touching anything. And let's see what happens. I may have to turn this off very quickly if terrible things happen. Okay, it's running. I hear high voltage. Okay, well, oh, that was the video connection, by the way, I think. That was good. Yep, that's just the video connection. Nothing to worry about. Well, the picture is narrower. The picture is narrower, but we still have the pin cushion. So it didn't fix that. I was hoping there would be some amount of change, but that was clearly not the case. And I'm assuming I can widen the image by turning this in. It is adjustable. And indeed, that is exactly what's happening. And it did not fix the pin cushion issue, that's for sure. Well, that's disappointing. I just figured it might have had some effect. I just thought that maybe because the inductance of this plus the yoke made it closer to the other one, it would have been around 1600, 2000 on the other one. I almost feel like there's just a fundamental difference in the way the windings are that must lead to this. I don't know. All right, so let's review what has failed so far. Reviewing the data sheet and the schematics for this set definitely indicates that there's no adjustment for width or pin cushion. And you need an adjustment for width in order to try to compensate for pin cushion by using that sawtooth output on the vertical deflection. Next, I measured the inductance of all the yokes I have, and I tried to put a 19-inch CRT yoke onto a 13-inch CRT, and that was an immediate fail. We saw that it had correct horizontal deflection and nice vertical lines. It did not have a pin cushion problem, but this one does. So I added an extra adjustable inductor, which allows us to adjust the width. So that's kind of cool, actually. That's something that's good to know if I want to do something similar in the future. But it had no effect on the pin cushion whatsoever. So clearly this yoke just isn't compatible with this board. So I guess at this point I need to keep my eyes peeled for deflection yokes that have the 30mm opening designed for 13-inch CRTs that have an inductance that is closer to what this board seems to want, which we've identified based on what works on the 1702 monitor, around 2000 microhenries for horizontal and vertical of around 33. They'll seem to work really well. And the one that's on here with the vertical around 21 obviously is working actually, so I guess that's fine. But it is the horizontal of 1474, which I assume is the problem. I assume. Like, I don't think this is an issue with the vertical. I don't see how the vertical could affect the horizontal size. So they seem totally unrelated. That's a separate part of the board, totally separate circuit. So, all right, well, I think that's gonna be it for this video. I was really excited to have like the thumbnail of like highest resolution 1702, but this was obviously a fail. And that's what you get sometimes when you're doing stuff like this. It's kind of like uncharted territory. And today I learned that 19-inch yokes are not compatible with 13-inch CRTs. I should have thought about that because it just makes sense that the shape of the bell is different, but I didn't realize it. I didn't use my brain, I guess. So, all right, there we go. If you liked this video, thumbs up. But if you didn't, you know what to do. Huge thanks to my supporters. Their names are scrolling up the side of the screen to make it possible I do this full time. If it wasn't for them, I really wouldn't be able to do it because YouTube ad revenue is in the toilet. And if it wasn't for Patreon and YouTube memberships, then yeah, it'd be very difficult for me. And if you have any suggestions or thoughts about what I've been working on here, definitely comment down below. And also beware of doing stuff like this because it is highly dangerous, high voltages, mains, all this kind of stuff. So if you do work on CRTs, make sure you know how to be safe. And if you don't do it. Just avoid entirely. And I think that's going to be that. So stay healthy, stay safe, and I'll see you next time. Bye-bye.